Curse Reverse is a game that introduces algebra. Students play the game by navigating through rooms with bridges and towers. We always start just by playing the game. I'm going to give you 15 minutes of free game time. What I want you to remember is this. Make sure you can hear your computer. So go ahead, click on New Game. Also, feel free to talk to your neighbor. How's it going, Sophia?
Really good.
Really good? What room are you in? After the first round of gameplay, it's important to have a discussion. The kids need to be able to say what's fun about the game, what was easy, what was hard, what was challenging, what are some tips and tricks they have to help their friends. It's important to talk about the game. Some kids will be confident with the math. Other kids will be confident with the game. It's important that they can express this with each other. What can you tell me you liked about this game? Sophia.
I like the music.
Okay, yes.
I like the flow of the game.
Having to really look at it and find the ratio.
I like the setting of the game.
What are some of the things in the game that made it challenging? Amethyst.
The little cues where it spits out fire or rock.
Ruff, what else?
What is it? Knowing that if you put the ratio too high or too low, something's gonna happen.
Figuring out that variable bar on the side is a challenge. How did you move the character around? What buttons did you push? Sophia, what buttons?
Arrow keys.
The arrow keys. Anything else about moving the character around? Is there any others? Yes.
There's using the letters.
Oh, so
WASD.
WASD, those also move the characters around. So you had a couple options, right? What is some things you can do that you could give your friends a hint about something you do in the game that makes it easier or makes you more successful?
Counting the grid.
Oh, the grid. Who noticed the grid on the game? Did you notice the grid and you could kind of count ahead?
Yeah.
Did you know you could turn the grid off? If you don't like it there, you can click it off. How far can you fall and still be okay?
3.
3?
3 squares.
3 squares?
Don't go in the water.
You also have to watch out for the spikes on the ceiling and the floor. Don't crash your platform onto the roof.
Who noticed on the side of the screen that variable bar that went up and down? What does the letter in the variable bar mean?
It's just a letter there.
Okay.
Like, because I also noticed that on the side, it was the letter, but it was also the same letter on the platform and the bridges.
Oh, so there was a correlation between the letter in the variable bar and the letter in the platform.
Yeah, basically.
Like it would make it bigger or smaller.
Okay. All right. So the variable bar could make the platform go more bigger or smaller? Who wants to play some more?
Me.
Get that one and then go the other.
During the second round of gameplay, students will share strategies while they're talking to each other. And that's what we want. We really want them to gain confidence so that they can build a community of collaboration. While I'm walking around, I try not to touch their computers or take their pencil because it's not my role. My role is to facilitate. My role is to prompt them into developing those math skills and those game playing skills on their own and guide them. It's the same for math development as it is for the gameplay.
Yes.
After the second round of gameplay, we put the computers away and do an inquiry-based activity. This activity helps students with their understanding of constants, variables, and coefficients. Our learning target for our activity is I can tell what a variable is. It's not just about solving expressions. It's my job to prompt students and ask the right questions so that they can understand what a variable is, how it works, and develop that understanding on their own. Where was it that you saw variables in the game? Was the n always equivalent to 3?
No, it could either be 2, 1, or less.
It could be a different number. So do variables, can they change their value?
Yes.
Yeah. How did the height of the tower change when you changed the slider over at the side?
Well, both of them would either have to be A or both of them would have to be A.
Oh, so
So they're similar in order for both of them to move.
so then the value of the A is the same no matter where the A is, right?
Yes.
During the key activity, we work together as a team to reveal a secret image. The students write expressions that will yield a number that will unlock a lock. We work through some of these examples together as a whole group, and then we split into small groups and use manipulatives to help write these expressions. Okay, I'm going to take 3 different dice and I'm going to roll them, and these are going to become my variables. Okay, I'm going to have 2 variables and a constant. What do you think a constant is? In the game, what was the constant? So I'm going to roll my dice, and I got a 5, a 3, and a 1. So I'm going to have my variable A will be a 5, my variable B will be a 3, and my constant will be a 1. Make me a snap cube tower with 5 cubes. You have 30 seconds. What was my variable for B? 3. So go ahead with the snap cubes and make me a tower of 3. So which variable is this one? A, and which variable is that one? Perfect. A, and which one is this one? B, and that's my constant? Okay. Now, to make my key, I get to pick whatever coefficient I want to go with my variable. Okay, now is that a new word for a lot of you? Coefficient? Here, let me write it on the board. It was 7A was 35 minus 5B. What was 5B?
15
15
equals 15.
equals what?
20.
I would come up here and I'd say, oh wow, my equation equals 20, so I can take the 20 off of the poster. So now you guys are going to do something similar. So everybody roll your dice, all 3 of them. Okay, both partners, write down your A, your B, and your C. Just pick which one you want for which. Okay, so everybody went ahead, rolled the dice, you wrote down your variables, right? Your variables are different than mine, correct? But your variables are going to stay the same throughout the whole paper. So every time you see an A, it's going to be your value for A. Every time you see a B, it's going to be the value for B. Your coefficients, you can pick whatever you want. But let's narrow it and keep it 9 or under, okay? Otherwise our sums and differences might get too large. I'll be coming around to talk to you about this. Let's go ahead and get started.
A was 6, so 1 times 6 is still 6.
And does the constant require a coefficient? Okay, can you write that as an algebraic expression? Perfection, you ladies. Very good job. Okay, so we got all of our locks unlocked. Why were some of the locks harder to get than other locks?
Because there's the chance that you'll get a negative number.
If they were odd numbers, they were.
Oh, the odd ones were more difficult? Did anybody else find that?
My team was getting even numbers, and then once in a while we would get this odd number.
So we had to times to get an even number and subtract to get an odd number.
Okay, good job. Was there anything you could do to your equation to help manipulate it to get to one of the numbers that was left on the chart?
You could make the numbers higher or lower.
Which numbers?
Your coefficient.
Perfect. After we have a discussion for the key activity, we have a 3rd round of gameplay. The gameplay allows us to reinforce key math terms and concepts. After that, we go into doing an exit ticket. The exit ticket helps us to assess where we're at and see what needs to be the next step. If you have a tower that is 3A, what does A have to equal to make a platform of 9? Okay, so you're going to complete that question on your paper. You can use the snap cubes, you can use a drawing, or you can use math, and then I'll be coming around to see how you're doing. So the last question says, represent 3A plus 4 if A equals 2. All right, so we all finished our assessment questions?
Yes.
All right, awesome. At home, you can try mathsnacks.com. You can go to any of the levels, because I know there's more stuff in there for you guys to try out because you haven't gotten to all the levels yet. What is it? mathsnacks.com. And try it out at home. In my classroom, I would probably spend an entire week working on curse reverse. This is a new concept for most students, and they need time to be able to understand it. The kids love it. It's a lot of fun. Most kids naturally are game players nowadays. They want to play games. And it's great that they can play games and learn at the same time and still have a whole lot of fun.